but I have also been recently involved in a project that is centered around fire standards. So my work really has been on how to make different systems talk to each other nicely. And that is what our talks today is about. So let me try to share my screen so that I can start presenting. Hopefully you can see my presentation.
Yes, we can.
Yep. Yeah. So let's start with why our team decided to choose Flutter as a technology to develop DHIS2 apps back in the time. So, I mean, basically, back in the time, we chose Flutter because from our experience, it was the most stable and productive choice compared to the state of Kotlin multi-platform at the time. So with Kotlin, we had to create we had to have two separate code bases for native UI. So you could have one code base for business logics. Then so for example, if you want to deploy your app for Android in the iOS, then you are required to write Swift UI and then native Kotlin codes for Android UI. But of course, right now KMP has advanced, and you can just write Kotlin codes to target both business logics and UI logics. But at the time when we were deciding to create mobile application, then Flutter stand out as a true cross-platform. So we could have one code base for Android, iOS, web, and desktop. But also it had a mature ecosystem, a robust community, extensive packages, and excellent documentation. So that's why our team at first decided to choose Flutter to develop the DHIS2 apps. So what is our goal? Is to not we don't want to leave Flutter behind. So the challenge really is when you want to create applications for DHIS2, then you have to interact with DHIS2 APIs. And now, so if you want to go with Flutter, then you have to reinvent the wheel and do a lot of things for it because Android SDK, DHIS2 SDK already handles a lot of things, authentications, often fast data sync, metadata management, and many more. So it saves months of the development efforts, but also ensures consistency and reliability. So we saw that it's an opportunity for us to use the DHIS2 Android SDK, and so now our goal was on how we can link the two. So how we link Flutter and the Android SDK that uses Kotlin for now. Yeah, so we have created a demo just to showcase that it's possible to link Flutter with DHIS2 Android SDK. And what we will do today is it's just a simple Flutter app to test the DHIS2 login feature. We know DHIS2 SDK supports a lot of features, but for this use case, for this demo, we just chose to showcase on how you can just use it to do the login feature. So we'll just build a simple UI that will have a place to input a URL, a server URL, username, and a password. And then we also have a chance to see real-time status updates from the native SDK. So the user login status and everything. So to follow along this demo, we have some sort of links. We have a GitHub repo. You can check the demo source code here at this repo, and the repo has two branches. We have two branches. One is method channels, which is one of the way you can connect Kotlin in Flutter, but also we have another branches of method channels with Pigeon, where it's another way. It's just an advanced way of the previous one. So you can use the Pigeon package to connect data, Kotlin in Flutter. So But also, if you want to see on how you can set up dependencies for DHIS2 SDK in an Android project, you have to check the DHIS2 SDK docs, documentations. But also, we have choose this plain instance as our test server. And if you want to refer a lot more about Pigeon package, then you can refer it at this URL. So something to note: the README files in each branch has up-to-date setup and instructions on how to get started with everything there. So you can have a demo run. So at the end of this demo, we'll be able to create this simple interface. As I said earlier, we'll have a server URLs on user inputs, and then we'll have a username and a password. We'll have a login pattern, and then we'll be able to log in, and we'll also be able to get those updates. And those updates are coming from the native Android SDK from DHIS2. Okay, so let's start with the first method, the manual, the method channels, which is one of the ways we can use it to connect with Flutter. So before I continue, I want to check if everything is okay and people are still seeing my screen. Is everything okay?
Yeah, we can see your screen and hear you fine. Yeah.
Yes. So the first approach is by using method channels. So basically, method channels are they act like a bridge between that codes and native codes. So you'll have a mechanism where you call a certain function in native codes, and the native codes receive that call and analyze and use the computation. And then after getting results, they send back those results into that code via method channels. So it's a Flutter-based mechanism for communication. It supports asynchronous message passing, and they use the string-based method names and dynamic data types. So about string-based method names, we will see about those in a few times. So the way this works, we have two parts. So we have a Flutter or that part, and then we have native Kotlin also. So this demo uses Kotlin as an example, but you can do the same in iOS using Swift. So the configurations involve two parts. So you have Flutter parts, which use that language. So in a Flutter part, you have this functions called method channel. I mean a class called method channel, and you pass it with the name of your channel. The name, you decide the name to use. So for example, in our example, we have used DHIS2.login the channel, and then so this instance, let's say we call it a platform, then we'll also be able to invoke those methods. So those methods, you'll be defining them in the native Kotlin code. So you invoke a method like a login, and then the native part will receive that that message that a certain function was called, and then we'll compute and then send back the results. So to understand that better, let me show the codes. So you can see my Android Studio.
Yes.
Yeah. Okay. Thank you. So as I said earlier, we have two branches. Let me go to the first branches, the method channels. Yeah, so here. So to highlight a little bit of the structure here, this is a standard Flutter project, and these are the files that we get in a Flutter project. But see, in most Flutter projects, our codes are in the lib folder, and the entry point is main.dat. But also we have platform-specific projects. For example, we have Android, we have iOS, macOS, and Linux. We have web, because these are the platforms that Flutter supports. And in most cases, you won't bother to touch anything in these projects. So you'll just be writing your codes in the main that you touch this package, you touch these projects when you have a specific use case that Flutter doesn't support by default. So for example, in our case, connecting with DHIS2 native Android SDK, Flutter cannot support that, so you have to touch a lot on the Android in the Android project. So as I said earlier, if we go to the main.dat, so this is an entry to our Flutter application. We have that function run up. So you run, you pass your class, and the class can be a stateless widget or stateful widget. So basically, widgets are the for example, if we were in the Kotlin, we could have said activities. Here in Flutter, we call them widgets. So a widget can be stateless or stateful. Just a little bit of context there. Stateless, stateful widgets are the ones that are state aware, and stateless widgets do not understand about the state of the app at that particular time. So we have our stateless widget here, my app, and then so every widget has this function called a build function, which is a function Flutter will call when it wants to render the UI in your application. So the build function here in my app will return material app, which is another class, and the material app has a lot of variables, but one of these variables is home, where I will pass my home widgets, and in this case, it's a login page. So login page itself is a stateful widget, and being a stateful widget, we get this function create a state. As you can see, we have to override it because we get this function from stateful widget, so we have to override it. So the created state, here we just say, when Flutter calls this created state, we just want to return the login page state. And the login page state extends states. And then, so here is our area of interest, is our area of interest. So we call this method channel. It's a default service binding in Flutter that is provided by Flutter themselves. So we define our method channel here, like DHIS2.login.channel, and we call it a platform. So just by doing that, we have set up a method channel, so where we can use that to communicate with native codes. And then here, this is just defining our form controllers and our login status. And then since this login page is state extended state, then you can we now get that advantage of having an init state function. So this is a function that Flutter will call first when this class is returned. So before it calls any other function, this will be the first one to be called. And what we want to do here is just to pre-populate our controllers with our server URL, with the server username and password. And then what we'll do here, we'll check the login status when our class is loaded. So the function to check login status, this is where it gets interesting. So here we have a variable called is login, then we call the platform.invoke method. Now we have talked about this function. So in invoke method, if you want to check the signature, you will see it receives a method, and also it receives another param, which is arguments of type dynamic, so they can be for any type. So here we have called the is user logged in to check if user has logged in. So let me just move from that code, then go to the Android part. So here is our Android project, and if we go to the app, source, and main, then to the Kotlin part in the main activity. So another thing I have noticed, if you open the Android projects directly from the Flutter, an interface that you have also opened the Flutter project, you want to get the auto completion and those Kotlin features. So I had to open this Android part into another like its own project, so that Android Studio then did handle the dependencies, did the Gradle sync and everything, so then we can get auto completions, and which is really very useful. So if I go to the main activity, this is our Android app. Android project. I've just opened it into another tab. So, and this is the main.activity. So here in the main.activity, the main activity extends Flutter activity, which is again comes from this package, io.flutter embedding engine. Android Flutter activity here. So this class provides us with this function which will override, which will configure Flutter engine in the main activity. And then there's a lot going here, but the area of interest is here. We have this method channel which comes here from this package, io.flutter.plugin.common.method channels. So here then we set we configure our Flutter channel, method channel. So remember we in the that codes we had a method channel called DHIS2.login.channel. So here we'll try to pass that name within this class method channel so we can have a two-way communication between Flutter and Kotlin. So from this method channel, then we get an opportunity of having this set method called handler, which is is a listener. And what it takes, it has call, which is an object that is received when Flutter calls a method in the that code, and we have result which we use the result to return the message back to the Flutter codes. Then we have a Kotlin way of handling switch statements where we use when. So in the call we can reference the call.method, and if the call.method is login, then this is what we will execute. And if it's logout, then this is what we'll also execute. And if it's user logged in, this is what we will execute. So you can see here in the login, then we want to where we then instantiated a D2 instance here. We had a D2 configuration object, and we passed it into D2 manager.blocking instance D2. Then we passed the D2 configuration here. So you may wonder why we have the two configuration. We have instantiated the two here in the login part, but we can also reference it into other. We can have the two instances into logout and its user login functions. The reason is the two instances are singleton class, so wherever you have instantiated it, you can reference it into other places also. Yeah. So after instantiating the two, then we try to get the arguments from the uh, from the functions, and arguments are from this object call. So the call.method, we can have a method name, but also we can have call.arguments to reference the arguments we passed into our Flutter codes. So then we can have server URL, username, password, and we have to verify them if they are all available. And then after being sure they are all available, then we come here to try to log in our user based on username, password, and server URL that user has provided. And then after that, these are just normal Kotlin codes where you will handle errors, and then you will return the response based whether it's a success or it's an error. So if you notice there in our in our dot codes, we call these methods by names like this. So for example, this login function, we call it by name, and I will also pass the arguments. And then in the Kotlin, we also have a chance to have an object where we can access this function name and the argument that have been passed and act accordingly based on what have been provided in the UI in the that code. So I hope that is a little bit clear. So if I try to run my project here, let me try to run my project and restart my emulator. So I do Flutter run to run our project. yeah, so this is our function. So as I said earlier, when we first launch our class, we'll check if user is logged in, and it will be the first method to be called. So we check if user was logged in, and this is a status we get from native DHIS2 SDK that user has not been logged in. So we try to log in based and credential that we have pre-provided. So if I try to log in here, yes, so we have been able to log in successful. So if I try to like edit the credentials, log out, and then try to log in again, I won't be able to log in because I have put wrong credentials. So that is it, and that's our first way of connecting Flutter with Kotlin, where we use method channels. So if I come back here in my presentations, um, yes, so that's way that approach works, but it's not tape safe. All that is dynamic. You rely on manual casting. So if you take a closer look here, this is how we passed down our credentials and arguments. It's a map. So method channels only support uh, basic and built-in data types that comes in with any language. For example, Boolean values, strings, maps. So these are the data types that method channel supports. But you cannot pass down custom classes. And passing down custom classes is very important and very useful because it's type safe, and it reduces the unnecessary errors. So with method channels, we cannot pass down custom classes, but also we cannot get back custom classes. So we'll have to rely on probably maps or strings. And then when you get the response, and then you try to convert it back into the normal custom classes. So that's one disadvantage of method channels, but also it's prone to runtime errors. For example, the way we call methods is by using their names. So, for example, I have used login here, and but also I've also been using, for example, is user logged in or log out. But if I will incorrectly reference this name and say, instead of say login, for example, let's say log in. I won't get any notification that this is a mistake. But until I have, run my project, then I'll be notified there is an error. But what if we could have, for example, a class, let's say called API, DHIS2 API here in that. And then from that class, I can get the auto completion of the methods that are available. So I'll be really sure that whatsoever I have called in that code, that's a correct method. We cannot have that with method channels. A lot of boilerplate codes for repetitive programming code for serialization, argument passing, and when blocks. So the argument passing, as we said earlier, relies on manual castings, for that's resulting in a lot of boilerplate codes. But also we don't have implicit contract. It involves implicit contract. The API contract is just an agreement between developers, not enforced by code. It's hard to maintain. So, for example, if you want to have an implementation where we support Android in the iOS, and then we want, for example, to implement 3 methods in Kotlin, in Android, then 3 methods in iOS. There is nothing that enforces a developer that you have to actually implement these methods both in Android and iOS. So there is no that API. There's no that interface or something. So that's where our Pigeon package comes in, which is approach 2. And Pigeon tries to solve some of these issues we have outlined, we have mentioned in this first approach. So basically, Pigeon is a package published by Flutter themselves. So you can see here it has been published by Flutter Dev. It's a Flutter Google Flutter team, but also it's a good project. It's a good package. And this here is how we check if a package is really, really good. So the number of likes, the number of downloads, but most importantly, points. So it has 150 out of 150 points. And the way they calculate these points, they check for readability, documentations, and if it's another safety. And they have other criteria for, trying to check if the package is really good. So Pigeon is really good package developed by Google themselves, and we will use it in approach 2 to try to solve some of the issues we have faced with method 1, which is a method channel. So to really understand Pigeon, let us go to the codes and migrate to the second branch. So I will try to migrate to the we have modified main.that and I cannot go to the, let me try to get main.that where it was, so that you can go to the to the next, to the another branch of all. This is how it was. I try to check. Yes, we are good. Yeah. So to understand a little bit of Pigeon package, it's as it show the dependencies. So if you want to know to know more about Pigeon, we have listed a Pigeon link here when we start our presentations. To follow along with Pigeon, you can get a lot more about and learn a lot more about Pigeon here at pub.dev on how to install it, to use it, and everything. Yeah, so this is what we get in Pigeon. So first of all, we have to define our API. What should our API contain? And you can put it elsewhere, but I have created a folder called Pigeons, and then in that folder I have a file called DHIS2 API.dat. This is where I will define my API. So I will import the Pigeon package here, and then I will have my API. So my API wants my API to have a login function. I also want to have this function called is user logged in, but also I want to have a function called logout. Then my login function receive credentials in terms of login credentials. We saw earlier with method channels, we received the credentials on a map in a map data type, but now we want to receive credentials in a custom class. So we will pass the custom class down to the Kotlin codes. So also the login function will return back a login result, which is also a custom class instead of just a string or a default data types in that. So then I have to define those classes. So here's where I define login results, but also here's where I define login credentials. Then on top of my class, I put Pigeon configurations. So what this class will try to do, it will use this configuration to generate first this API here in that and in Kotlin. But also if I want to implement this feature in Swift, but I will also put some Swift params here to define where Swift code should be auto-generated and those kind of stuff. So in the configure Pigeon, I have this object Pigeon options where I define where that codes will be generated. So these are the DAX codes where so the API will be generated both in Dart and Kotlin. So then I have an option to describe where my DHIS2 API in Kotlin should be generated. So as you can see here, I passed the full paths. In Android app, source main Kotlin, com example, DHIS2 Flutter test imply, and then in this file called DHIS2 API.g.kt. So you may be wondering why G. So G is a convention in that to notify that this class is, this file is generated. So user or developers should not directly edit anything in that file. It's a generated file. And then we have to specify that package name. Yeah, so that's it. But also we have to define error class name. So this is a custom class error that will be returned back whenever anything goes wrong. And then this will be a class that is, thrown to make sure the code is clean and everything, runs as expected. So after defining this interface and then configure this option, then I will have to run the command. So the command basically is Flutter pub run Pigeon. So we'll do Flutter pub run Pigeon. Then you specify the where this file is located in terms of path. So for example, my DHIS2.API.dash is located at lib then slash Pigeon, pigeons. Yep, slash DHIS2 API.dat. So if I run this command, then Pigeon will analyze this file and then know what to do. So as I said, as we said here in our configurations, our output should be generated here. So I have already run that command, so I want to run it again. But if you haven't, if you have configured your configurations and then so it's the first time, you have to run that command to actually generate those boilerplate codes. So the codes will be generated here at lib, then generated as we have specified here. And here generated, then we'll have this class DHIS2 API.c.dat. And then inside here we will have our implementation of that interface. So this will be the class and everything that will be used on the that side. And also if you come here at the Android project, we'll also have this file generated, DHIS2 API.g.dat. And if you take a closer look to this file, you will see we have that DHIS2 Pigeon error class that we said we want to have that class, but also we have login credentials defined into our Kotlin. We haven't written this codes. They have been auto-generated by that in our Kotlin project. But also we have login results data class that will also be used to kind of pass data from Kotlin back to that code. So I'll move to the other side where I opened my Kotlin project to get auto completion and to check if everything is well in place. So we have our file generated here. So this is our main activity now. But before we take a closer look at the main activity in Kotlin, let's just check out on how we have changed our implementation in Flutter from previous implementation that's the method channel without Pigeon. So here in that now, so instead of specifying the method channel here, we now instantiate this DHIS2 login API, which is an API generated after running that function, after running this command, where then Pigeon will analyze our interface and then generate a class for us. So we instantiate that class, and this class will provide us with those methods, and then we use those methods to communicate with that. And now you may be asking yourself, so where is the configurations for method channels and on all this? So this package handle that on our behalf. So it will create it will create that channel on our behalf. So now we just have to call and instantiate the DHIS2 API here. And now we then, instead of passing function or calling functions as names, we now call functions as normal functions. So we have the DHIS2 API, and then we have that functions called is user logged in. But also, if you come to the login function, we now call the login function instead of passing down a name. But also, we pass credentials as classes, as custom class, which reduces now errors, and our code become a little bit cleaner. So if we go back to the main activity in Kotlin, so we have our normal configure Flutter engine as usual. But now instead of passing down our method names, we passed our DHIS2 login API that have been generated by Flutter. And we make sure that main activity extends that API. So here in the login function, now the login functions receive credentials in terms of custom classes. This is a Kotlin custom class that have also been generated by Pigeon package. And then also receive a callback. A callback takes in a results in terms of login results, and then we'll use that to return the result back to the dashboards. So it's inside here we use coroutine to make sure these codes run on the background, and then we use we instantiate the DHIS2 as usual as what we did in the previous approach. So the rest kind of remains the same, but what we have improved now is we no longer pass arguments, or we don't call functions using their names. Instead, we call functions as normal functions. We also pass in arguments as custom classes, which somehow reduces errors. Yeah. So that is it for the two approaches. If I go back to my presentations, we had a chance to have a closer look into how Pigeons works and how to set up Pigeons. So we have done that. We have seen how we define our APIs and the interfaces using Pigeons. So what are the advantages now of using Pigeon? So before, in a manual method channel, then we had to invoke the methods using their names. But using Pigeons, then we call the functions as functions. But also we pass in arguments as custom classes instead of a map. But also we get the advantage of having compiled type safety, no magic strings. I mean, we don't call functions using their names, less boilerplate codes, and split and self-document API. So about self and documenting API. So if you come back to the to our codes, we have this API that is somehow generated. And if you take a closer look to it, it defines these functions. It's an interface that have these functions. So any class that extend this class have to implement these functions. So as you said earlier, if we have another implementation in iOS, we want to do the same features, we will have an interface generated in iOS code by Pigeon, and it will have to specify the three functions. So the entry class in Swift will have to like implement that interface. So by doing that, we'll be sure that both our Android implementation and iOS implementation, all of them have implementations of all the functions that we need and everything that we need for our APIs. So by doing that, we can have a common implementation in both Android and Kotlin. So that's what we get. So what are the limitations? So the limitations that you have seen. Current limitations, this demo has focused on Android, but the same implementation has to be done on iOS. So for someone who is doing, for the team which they're doing, because platform they want to put their app in both iOS and Android, it's a little bit duplication of efforts because they have to do the same thing in Android and iOS. And then another thing is native dependencies. You still need to manage the native DHIS2 SDK dependency and build.gradle and the configure settings.gradle. This process isn't automated, so you have to manage those dependencies manually. But if you want to refer on how you can do that, I think the README files in both branches have defined, have explained on everything in details. So I think that is it. But so we had a chance to like explore those two approaches, but also we want to like explore more on FFI, which is foreign functions interface. It's a way where you can call native codes in that without even like specifying or going around all this implementation that we have seen around these previous two approaches. So we just call that code directly into, you'll call native codes directly into that without doing a lot. So FFI works for iOS, but we have Gen that works for, Kotlin. So we want to explore more on that, and I think we will update the UIO 100 team on how that also can be done. But for now, we have tested those two approaches, approach 1 and approach 2, and that is it. Thank you.
Yep, thank you. Thank you a lot for your presentation, Yusuf. Congratulations for the work you have done. I mean, really clear and really well explained. So I'm going to stop the recording now.